Hello guys, welcome once more to another video on our YouTube channel. So in this video we are going to be talking about polynomials, where we are going to combine the polynomial topic alongside partial fractions. So basically we are going to create equations together. Okay, I'm just going to show you what I do to create equations sometimes, which is not actually difficult. Okay, so for example, if I want to give you something like x to the power, in fact, for me to make equation to be difficult, that is equation to be sensible, because if I give you, for example, 1 divided by x squared, no, let me say x plus 2 divided by x squared plus 1, to resolve into partial fractions, you realize that the denominator is a function you can easily deal with because it's a quadratic and it is clearly irreducible because the determinant is negative. So you can first of all say, okay, this is already in a partial fraction. Let me say, in fact, let me just attach another factor to it, maybe x, yes, or x plus 1. Then 2x plus 1. Okay, now here you see that the functions in the denominator can easily be dealt with because this is a quadratic and this is a linear function. Okay, so generally whenever you're given maybe a partial fraction, maybe f of x divided by, let me say, g of x, the first thing to always verify is if if this fraction here is a proper fraction or it's an improper fraction. That's the first thing to verify. If it's a proper fraction, we now check if the denominator, which is g of x, is a polynomial that can be reduced or factorized. If it's an improper fraction, you first of all do long division. Okay, what is a proper fraction? It's basically a fraction where the degree of the numerator is less than that of the denominator, while an improper fraction is a fraction where the degree of the numerator is greater or equal to the degree of the denominator. So in cases like this, you always verify if the fraction is proper or improper. But like I said, we just concentrate on the methodology I used in creating equations. So for example, if I want to give you an equation like maybe x to the power 4 plus 1, for example, maybe 2x plus 3, for you to resolve into partial fractions, you realize that this is a quatic and you will need to first of all think about factorizing this quatic, which is not an easy process. Okay, it's not actually an easy process just by looking at it for the first time. Okay, so I'm going to start by helping you to factorize this quatic. When you factorize it, and I'll guide you again to resolve this into partial fractions, because this is clearly a proper fraction since the degree of the numerator is 1 and the degree of the denominator is 4. So we basically now go to the denominator and check if the polynomial in the denominator can be factorized. But we know about quadratics, we can easily check their discriminant. If the discriminant is negative, we cannot factorize it. If it's greater or equal to 0, we can factorize it. Then we find steps in factorizing it. But this is a quatic and it's always a little bit complicated to check if it can be factorized. Okay, so that is why maybe if I want to give you such equation, I will start by guiding you through factorizing this quatic, and then from there you now resolve this fraction into its partial fractions. Okay, so for example, I recently said something for your CA, that's St. Benedict students. I recently said something for your CA. Those who got in S1 and S3, yes, your exam was very good, and let me show you how such equations are formed. Okay, so for example, if I want to give you, maybe I'll just sit and say, okay, x to the power 4 maybe plus 9 times x plus 4. Okay, I will try to expand this, all right, because the original equation will be that you should actually resolve this into partial fractions. Maybe no, x to the power 4 plus 9 times x plus 1, for example. The original question would be that you resolve maybe 3x minus 1, that you resolve this into partial fractions. They realize that this is a proper fraction and the degree of the denominator is 5, but there is a quartic here which is very difficult for you to easily factorize. So I will start by guiding you to factorize that quartic. But even before doing that, this is what I'm going to do. I'm going to just expand the denominator, because you see the denominator is already kind of factorized, right? Though you need to factorize this quartic again. But if you multiply this, if you expand the denominator, we have x to the power 5 plus x to the power 4 plus 9x plus 9. You see, so I'll start by giving you in fact the objective is to resolve this into partial fractions. Okay, so I'll start by giving you the polynomial in the denominator. Maybe let f of x equal to x to the power 5 plus x to the power 4 plus 9x plus 9. Now, and g of x maybe equal to x plus 1. You see, you realize that then I'll now say maybe determine the function h of x such that f of x is equal to h of x times g of x. You clearly see that your h of x from here, okay, is just equal to f of x divided by g of x, which you can now do long division. So my g of x is simply x plus 1 and my f of x is equal to this. You see, you're not actually going to know that it's equal to this, because at the end of the day I want you to factorize f of x completely, but you start by first of all getting these two factors. Okay, so you realize that your h of x will just be equal to this quotient x plus x to the power 4 plus 9 when you carry out long division, because if you replace this numerator here with everything here, okay, me who set the equation, I'm not going to take time to solve it because I already know what we are supposed to have at the end of the day. So x plus 1, because the numerator I'm just going to factorize it this way, okay, and you're going to have x to the power 4 plus 9. So this is your this is your h of x. Maybe you can have 2 marks or 3 marks for doing the long division. That's Euclidean algorithm. Okay, now maybe the next question can be, now I'll now guide you to factorize this. And how do I guide you to factorize it? I'll first of all factorize it by myself. Okay, so I'm going to say x to the power 4 plus 9 is equal to x squared all squared plus 3 squared, and now use the relationship between alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. Yes, minus 2 alpha beta. So this just gives us 6. So 6x squared minus 6x squared. Okay, now I'm going to further write this as x squared plus 3 all squared minus the square root of 6x all squared. And then I now use difference of two squares. So I have x squared plus 3 minus the square root of 6x times x squared plus 3 plus the square root of 6x. To rewrite it in the basic form, we have x squared minus the square root of 6x plus 3 times x squared plus the square root of 6x plus 3. So I've basically factorized this maybe in my rough work. Okay, but I am not going to guide you through this part to factorize. I will now say, okay, maybe determine the value of the constant, maybe lambda, the value of the constant lambda, such that x squared maybe plus lambda x plus 3 is a factor of h, or determine the values of lambda such that this is a factor of h of x. You clearly see that your lambda will be equal to minus good 6 or plus good 6. Okay, but I'm not going to guide you through this way because I want you to perform some work so that you get marks. All right, so with that we we basically need to do long division, because your h of x should be equal to, in fact, if you take h of x divided by x squared plus lambda x plus 3, you should have a quotient with no remainder. Okay, so you first of all do the long division and then you equate the remainder to 0. That is long, I cannot do it here. You do the long division, you equate the remainder to 0. I think I corrected this in class when we're doing the correction of the CA. So you do the long division, you equate the remainder to 0, and you're going to find the value of lambda, and lambda will give you plus or minus good 6. So you clearly see that your h of x will be equal to, maybe your h of x, okay, h of x will be equal to maybe the quotient which you had, which is going to be in terms of lambda times that x squared plus lambda x plus 3. Maybe with that specific value of lambda, if you choose lambda to be the square root of 6 positive, you're going to have this. Now, how do you get your quotient? Because it might be the next question. Your quotient is simply gotten by replacing the value of lambda in the quotient you had after long division, because the quotient you're going to have after long division is going to be in terms of lambda, and when you replace the value of lambda, you basically have this next factor here. Okay, you basically have this next factor, and then you see that, okay, your h of x is equal to the product of these two factors. Now at the end of the day, I can now say, okay, this was actually the main aim of the equation to resolve this into partial fractions, and you're going to tell me that, okay, this is this is equal to 3x minus 1 divided by, now this denominator has been first of all factorized into this, okay, because you clearly see that your f of x is h of x times g of x. This is h of x and this is g of x. So you first of all tell me that this, and then now this h of x here has been factorized again into these two factors. So you now see you have done factorization again. You have factorized g of x, h of x, into its two quadratic factors. Now you realize that the functions in the denominator, you can easily deal with them. This is a quadratic, and you need to verify if this quadratic can be factorized by finding a discriminant, and you're going to realize that the discriminant of this quadratic and this quadratic are all negative, so it cannot be factorized. So the form of this partial fraction is just, since these quadratics cannot be factorized, it means their numerator will be linear. So x squared minus the square root of 6x plus 3, then plus cx plus d, since the quadratic is irreducible, x squared plus the square root of 6x plus 3, and finally we have a constant term, so the numerator has to be linear. That is the form, and then you look for the LCM, you create your equations and solve. So basically that is how the equations are being set. Okay, so don't think that the equations are taken from space. It's just basic manipulations, and so that you should basically understand the main aim of every examination. All right, so if you have a difficulty in the long division, do well to comment in the comment section. Thank you once more for watching, and I wish you all the best in your second sequence harmonized examination.